there are some atoms that have more oxidation numbers than just one, and most of them are your nonmetals or your transition elements. Okay? For example, we aren't doing the transition elements yet today, but iron can bond with chlorine 2 different ways. This is cute. Okay? In the top one, what does it appear that iron's oxidation number is? And in the bottom one, it appears that it's what?
3 plus.
No, that's right.
3 plus. Guys, the first one's always positive, and you can uncrisscross to find the charge because iron is not one of those guys that is an obvious oxidation number. Now look at it. 2 plus, 3 plus. Okay? There also is, when we start doing ionically bonded things, it gets a little bit more complicated. Pull out your books. Turn to page 185. You miss me coming? Oh.
Practice.
Look at Pt2. What the heck? Chlorine and fluorine. Natalie. Us.
That's really funny. I don't think I ever noticed that. Almost positive I am.
Why does it smell like really?
Okay. Alright. So on this we have a little table. It says compounds of nitrogen and oxygen. So if you look, there are 5 different compounds there of nitrogen bonded with oxygen. Some of them are pretty, I don't know, harmless. And some of them not so much. Okay? So the first one there, we got a white and colorless crystal solid. Doesn't appear to be do too much damage. The next guy is your toxic brownish gas. Okay, so there's some gases that don't do a whole lot. For example, the very bottom one will make you fall asleep. Laughing gas. The NO2 will make you fall asleep permanently.
That's so sad. Wait,
Yes.
What nitrous oxide is used in cars? If we go back to
Like NOS?
is that nitrous oxide?
I don't know. What? I'm not a big car person. Do you know?
People call none of them are written down.
Yeah, they call it nitrous oxide.
The nitrous oxide isn't written down.
It's at the bottom.
I wonder if they
Smell it up.
Sure. Yeah, I don't know. I would assume it's not laughing gas that they're using.
It makes the car giggle when it goes fast.
I've never been under.
Okay? So now notice, the thing I'm trying to show you here is all 5 of these compounds, the nitrogen has a different oxidation state.
What is that?
Oh, would you look at that? In the first one, its oxidation state is +5, and the next one +4, +3, +2, and +1. So it has 5 different oxidation numbers.
That's fun.
And there's a 6th oxidation number as well. It's 3 minus. They don't have the +1 on here for whatever reason, I'm not sure why. Okay? -3, +2, +3, +4, +5. And that's because when you do covalently bonded things, it acts a little bit differently when we talk about trying to figure out what the oxidation number is. Okay, so this leads us into a polyatomic ion. These are the things you guys will probably dread. Just saying. But it's okay. Yes.
It says that when they make it really cold, it will cause it to work like what they use in cars, and then when they warm it up, it'll be like laughing gas.
Huh.
Well, make sure it's not cold. At the doctor's office.
Undesired effect.
What'd you give him? Sweet. Okay.
It's the big room.
So, what a polyatomic ion is, it's first off, it's covalent, okay? But it's a group of things that's bonded covalently, but it also has some interesting properties in that it has a what? Charge. Okay? So you're typically going to see these covalently bonded polyatomic ions involved in ionic compounds.
We have to memorize these common polyatomic.
Yeah, you do.
Nice.
See these? You gotta memorize them.
That sucks.
All of them. And then I would do so quickly.
Are we gonna have a pop quiz? Great, quickly is in tomorrow.
Okay, let me just show you a couple trends that might help you out. Should help you memorize these. You need to know the name, you need to know the formula, and it's also very important to know the charge. And I will show you why when we start doing the formulas for these guys. Okay? Just a little caveat here. You see 8 and 8 a couple times here. 8 is always going to have more oxygens. 8 will have less. But if you're just dealing with one of them, it's going to be hard to know exactly. 8 has 4, 8 has 3. Here, 8 has one more than 8 does. 8 will always have one more than the 8 one, assuming you're dealing with the same thing like nitrate, nitrite, sulfate, and sulfite. Now I realize there isn't a carbonate, but if there was a carbonate, it would be like CO2. But there isn't such a thing as a carbonate.
There is in Star Wars. When they freeze
Oh,
in the
so
back.
Yay.
Gotcha. Yeah. Okay? Now, there is no real easy way to memorize this other than you just gotta memorize it. Okay? I don't make you do that very often, do I?
Yes.
No, I really don't. Stop it.
Wait, so when do we have to have this memorized? Preferably by next
By Monday,
By your test.
which is
A ways away.
No quiz?
There'll be a quiz. I'm not telling you when that is.
We can.
This Wednesday?
No.
Here, let me look through my notes and see what.
Well, there's a good diligent student. Okay, now there were 4 oxidation rules that we dealt with last week, Thursday. We never had school Friday. Okay, so oxidation number rule 5 says the oxidation numbers of all the atoms in a polyatomic ion add up to its charge. So let's start with an easy one, OH minus, that's called hydroxide. Okay? Now, what's very difficult when you're doing covalently bonded things, okay? You need to identify what is the most electronegative element in the polyatomic ion, because that's the one that you're going to assign the true true oxidation number that you would expect. And I'll show you what I mean here in a sec. Okay? Which one's more electronegative? Hydrogen or oxygen? Now this one works out. So -2 I'm going to assign as true oxidation number. Now it just so happens that this has to be +1 for it to give you an overall -1 charge. That's what this rule is stating. Let me give you a little bit more difficult one, like your NO3 minus. Okay?
yeah, that's cool. Yeah, no, just kidding.
Okay? So again, when I'm doing this, I have to figure out which one's the more electronegative of the group. Which one is? Definitely oxygen.
Where's 90? Before oxygen.
Well, if you sit up and look, you might be able to find it. So I have to assign oxygen with its typical or normal oxidation number, which is what? Okay. Now, nitrogen has the ability to have a whole bunch of oxidation numbers. First off, it's going to be positive. It has to be. Okay?
Plus.
Oh.
Plus 5.
It is +5.
So you get the 3 and the...
Because I have to have my oxidation numbers add up to give me -1, and if I have 3 of them,
How does that give you negative?
Oh.
everybody see it?
I got it.
Okay, these polyatomic ion guys are a little bit goofier. Let's see. Let's do the NO2. Again, this is still going to be -2 because it's the more electronegative. In this case, nitrogen has an oxidation number of +3, and the reason why is I've got 2 oxygens. Give me overall -4. Do I still have the charge of my polyatomic ion now? Okay, +3 -4 gives you -1. Okay, these are a little bit trickier. Okay, the reason why the oxygen is the -1 is because since it's more electronegative, it's going to have the stronger pull, which means it's going to have more of those shared electrons to itself than the other guy. Okay? Let's do this guy. We are going to now do some naming of a little bit more complicated things. It says, what is the formula of the compound that contains these 2 guys? Now, first off, you're probably thinking, if I bond all of these, won't it be covalent? Because they're all what? Non-metals. However, these non-metals have a what? So they are actually going to bond ionically. So we are going to treat these like we treated the ionic compounds on Thursday. Okay, there are a couple little small tricks to this though. Okay, still follow the exact same rules. Write the positive guy first. What is this guy's oxidation number?
+1.
+1. How do you know that? The charge of a polyatomic ion determines the oxidation number of the whole thing. Now, yes, are these guys going to have distinct oxidation numbers? Yeah, but the overall oxidation number of the whole thing is +1. Okay? You're going to want to pay attention to this. You're not going to want to be falling asleep on this. Followed by your PO4 minus. What's its oxidation number? Okay, and then what's next from the rule standpoint here? Crisscross down.
Oh my goodness.
Now, is this correct?
No, put parentheses around it. NH43.
This is not correct. This is what a lot of students do. Okay? The reason why this is not correct is, do I have ammonium polyatomic ion anymore?
No.
No. I somehow put 43 hydrogens around nitrogen. Is that categorically possible?
No.
Unless we find some exception someday.
Okay? It's not possible. So we have to show some way to say that, no, I don't have 43 ammonia or hydrogens in ammonium. I really just have 3 ammoniums. So here's how you do this. Whenever you have more than one polyatomic ion in a formula, you must put parentheses around it. So let me show you what I mean. So I have more than one NH4, so it looks like this when you write it. What this tells you is I have 3 of this whole thing. It's not as bad. Okay? It's really a bunch of little rules that start to build, and if you miss a little rule, it could hurt you. So stay on task, especially in this chapter. Okay? If I don't have parentheses around a specific polyatomic ion, what can I assume about it?
It's just one.
It's just one. So how many phosphates do I have? Just one. And I have 3 ammoniums. So I needed 3 ammoniums to bond with the 1 phosphate. Why? Why did I need 3 ammoniums to bond with the 1 phosphate?
Because
Yeah. In order for me to get a neutral ionic compound, I needed 3 of the positive guys to overcome the 1 guy that was 3 negative. Or to cancel it out.
Oh. Okay.
Okay?
Okay.
I will. Let me see here. How many more do I want to do with you guys? And then let you use why don't I have you guys try to do all of these, and we'll go over them.
Okay, let's do the first one again.
Same rules as Thursday. Only difference is if you have more than 1 polyatomic ion, you have to do what?
Do the first.
That's it. That's really the only difference, other than you got to know.
Sulfate. What is sulfate? What is that?
Oh,
there it is.
yeah.
I was just okay.
Now, are you guys starting to see why you need to memorize the polyatomic ions right off the bat?
Yeah, I know.
Because how am I going to be able to write a whole long equation if I mess up the very first formula that has a polyatomic ion in it?
Isn't the first one kind of simple though?
Wait,
It
yeah.
ends up being
You just
simple,
cancel it.
but again, if you follow the rules and stay with me as we do this stuff, I think you'll find it's not overly difficult.
It's a little too negative.
That's its charge and its oxidation number. So you have more than one of it. I do not want you to put parentheses if there's only one.
We just distribute.
Distribute what? No. That changes what it is. It's no longer ammonium. It's something that isn't possible. Do not distribute. The only way you would distribute if you were trying to count atoms, which we'll do that when we balance the chemical equations. Okay. Okay.
Yeah, it doesn't.
There's a rule.
Phosphate.
Right here, number 4. What does it say?
Acetate. Well,
Okay, 2 and 2 reduce.
Yes.
So then you would not write the 2 here. And secondly, calcium isn't a polyatomic ion, so you wouldn't put parentheses on it anyways.
I'm never saying that now.
Well, it's not even a polyatomic ion.
Yeah. What the heck?
So the only time you put parentheses, if it's a polyatomic ion that you have more than one of. In this case, for that one, it is just CaSO4.
What is this?
Oh, you guys don't know what acetate is.
no, we
I didn't make you memorize that polyatomic ion, so I'll give it to you. Here's acetate.
Bless ya. Bless ya.
Oh, thank you
That's
for not
acetate.
making us memorize that.
Yeah. Figured I'd save you a little bit of trouble and make you not memorize acetate. You alright there, Bremen?
Absolutely not.
What you confused about?
Yeah.
Life in general. So.
I'm gonna let you squabble a little bit here. You should at least try. I'm gonna go over them all.
I know, that's what I'm waiting for.
Don't you don't think there's any?
Oh, I wrote down some letters and some numbers. Really don't know anything. I see that's Tom. I know this.
This is what the homework is, what we just did.
Yeah. Your homework is going to be what you're doing right now.
Is copper 3 like, would 3 be its oxidation?
Yeah.
But
Yes,
there's
sir.
no copper. They can't have it.
It's possible that I'm making up ones that aren't true.
Okay.
But okay, let's go through these. I'm seeing more people that need help than I anticipated, so let's go over this. Okay, so that means even if you don't think you need help, you're going to stop and pay attention. Okay? Alright? This is done exactly like we did the stuff on Thursday. The only difference is you got to know what the polyatomic ions are, and you got to know one thing. Parentheses around the polyatomic ion if you have more than one. Okay? Calcium and sulfate. So we know what calcium is, right?
CA.
Ca.
Oh, yeah.
Okay, now sulfate, this is why memorizing that particular chart is going to be important, because what people are going to do on a test or a quiz is they're going to do that. Think it is sulfur. It would be sulfide if it were sulfur. So, it's not just S. Sulfate is a specific polyatomic ion, which is SO4, and what is its charge? 2 minus. That would be its oxidation number, correct?
Correct.
Right? What's calcium's oxidation number? Okay. Element, symbol, oxidation number. Now we take and do what with those? Crisscross down. However, there's a rule that says if you can reduce, you do so. Can a 2 and a 2 reduce?
Yeah.
Yes, it reduces to a 1 and a 1. And we don't write ones. So do we need any parentheses in this case? No, because what we're going to have is one of each, and so your guy will just simply be that. Now, it isn't going to be like that all the time. Just so happens that that's how it works out for this guy.
By the way, they take away the 2 minus?
Yes, no one ever end up having the,
Yeah, that
the
was
chart.
my last question.
Yep.
Just.
Well, then, in that case.
Okay, next guy. Now as we look up here, we have 2 polyatomic ions. Okay, we got to figure out what they are. Ammonium. What is it? NH4 plus. So plus would be its oxidation number. We'll put it there, above it. Correct? Following? Carbonate. Now here's the number one way to know you have a polyatomic ion in it. It has an 8 ending or an EM ending. When we get into actually naming, all the other guys will have an IDE ending. IDE. There is one polyatomic ion that has an IDE ending. There's only one. And it's hydroxide. All the other ones either end in 8, ite, or EM. Okay? That's how you know you have a polyatomic ion quickly. Now, whether or not you can write the polyatomic ion will be determined by whether or not you memorize the list. Okay? Carbonate, CO3 2 minus, so 2 minus is its oxidation number. Okay. Then we do what? Crisscross. Okay, so that means I'm bringing the 2 down here, which means how many NH4s will I have?
2.
2. Is that more than 1?
Yes.
So what do I need to do?
Parentheses around her.
With a 2 there, now that distinguishes that it's not 42 hydrogens, it's 2 ammoniums. Does that make sense? Now how many carbonates will I have?
1.
1, because that's going to crisscross down. Now, how many oxygens are in one carbonate?
3.
There are 3 oxygens in one carbonate, but there's only 1 carbonate. Does that make sense?
And you take away their oxidation.
Yeah, we never left the oxidation numbers when we were doing it on Thursday either.
I know, I thought, but like since they're weird, I thought you did something.
Nope. Okay, now Potassium phosphate, this is the actual name for it. So we're going to take the name and write the formula. Potassium is what? K. Now is that a polyatomic ion?
No.
No, so we're going to look at the periodic table to find its oxidation number. What is it?
1 plus.
Okay, there's an 8 ending. That must mean it's a polyatomic ion. So go to your little list and you'll find that it is.
Oh,
Minus is its oxidation number and charge.
Should be K3PO.
Now, here's what some people think they have to do. Do I have to do that?
No.
Why don't I have to put parentheses here?
It's not a polyatomic.
Because it's not a polyatomic ion.
this is getting awkward.
Did you do that?
Yeah.
I put the 2 up top on the second one. Is that wrong? Like an extra
Like up
one?
here? Yeah, don't put it there. Okay? K3, because they would crisscross this down, crisscross this down. You're not going to write a 1, and since I only have 1 phosphate, do I have to put parentheses around it?
No.
So in the list, there's 10, and then the charges go -3, -2, -2, -2, -2, -1, -1, -1, -1, plus.
Really? You found a trend.
I don't know any other terms.
Okay? This one's the harder one to. This one's the harder one. We can't just give it an acronym and call it good. It's a little bit more work here. In fact, I bet you a lot of you after Thanksgiving break will have forgotten your molecular geometry chart because you just had a nice little acronym that helped you cram real quickly to.
I don't remember trying one.
Okay, here we go. Again, still we got potassium. We know potassium is K plus, or plus 1 because it's in group 1. Nitrate, there's another polyatomic ion, AT ending. And O3 1 minus, correct? Ah, ones and ones. Can't, well, they're in their most reduced form. We don't write 1, so are we going to have to put parentheses anywhere?
Oh.
No. So it is just KNO3. So here's what ends up happening, guys. Here's what ends up happening. When we start getting away from the writing and naming these guys and start doing the chemical equations, a lot of times what ends up happening is people forget to do the rules that we've been talking about up to this point. And so when they get to writing the chemical equation, they don't put K3PO4. They do KPO4. Because they don't remember that there is a method that you have to follow when you are writing the formula. Questions so far? Anyone? Okay, acetate is this. It's another polyatomic ion I didn't make you memorize. Okay, what's ammonium? Or CN. And now you'll be able to probably remember some of these guys because we'll do them a good amount. Turns out that this is a 1 and 1 charge as well. So would I need parentheses or anything like that? Nope. Our charges and got ourselves a compound. All right. I'm gonna talk much more about this, I think, tomorrow. Anybody remember what the Roman numerals tell us?
That's the oxidation number.
It tells us the oxidation number for transition elements, because we don't have anything that we've talked about up to this point that's told us how to identify. There's no trend for transition elements oxidation numbers. I mean, you look at it, you got +2, +3, +4, +7. This can be +2, +3. This can be +2, +3, +4. This can be +2, +3, +4, +6. So how are we going to know? You're going to have to be given Roman numerals, and if you write the name, guess what you're going to have to do? Identify what those Roman numerals are. But we'll get to that tomorrow.
What is chromate?
Chromate, CrO4 minus. Okay, so copper. Cu at the copper mine. 3, now is it 3 minus or 3 plus? Why is it 3 plus and not 3 minus? Because your oxygen's the minus, the first guy's always going to be your cation or your positive guy. Is there any polyatomic ions here?
No.
No polyatomic ions, no goofy business. Crisscross and be done. Okay, last one, copper and a carbonate. Copper 1 plus, what's carbonate? Crisscross down, do I need to put parentheses here?
No.
I don't have to put parentheses, I have more than one copper.
No, no. It's not a polyatomic.
It's not a polyatomic ion, so your answer would be this. If you are struggling at all, coming after school, do your worksheet in my room. This is one of those things where slowly we're building, but if you mess this day up, tomorrow and the following days will be more and more difficult. Okay, I promise you won't have too much difficulty if you come in and we work together for a little bit.